Good afternoon. Thank you for hanging in there after lunch. I do a lot of speaking, and this is generally the worst one, although I feel bad for the last guy here. There's this point at which lunch digests and the eyes go down, and it's like clockwork. So I'll try to keep going here. I am from Raytheon Integrated Defense Systems. It's one of the larger divisions of Raytheon, and most people here know Raytheon as a defense firm. We keep many, many countries around the world safe with various radars and missiles. But if you've ever in your life taken off in an airplane or landed in an airplane, it was a Raytheon radar that guided you in as well. And a lot of those type of products and services. A lot of weather data comes from our satellites, et cetera, et cetera. So why do I have that introduction and this kind of fluffy vision and mission statement up here? Well, at Raytheon, it's not so fluffy to us. We actually decompose every word in these statements, and they end up in our operational activities. So if you look down at the bottom, you're going to see three words: safety, stewardship, and stability. And when we kind of took a step back about 5 years ago, deciding about what are we going to do about the future as a company, and we were thinking about forming a small innovation group, we kept going over those words and realizing that if you take a larger umbrella view of what Raytheon does, it would not be out of character for us to look way beyond defense for things that increase the stability, safety, and security of the world, of people in the world. That's what birthed the Mission Innovation Group. And essentially what we are, for lack of a better term, is an innovation incubator. And we take technologies that we know well, our core, which is the bottom V there, and we take technologies, money, partnerships, universities, governments in from the side, things that we don't have but we feel we need to make a solution for a problem that's coming down from the top. So we look first and foremost from the top down on the V, and we say what problems are out there in society: hunger, pollution, medical issues, transportation issues, all sorts of things. What's out there, and what can we do about it with some of the Raytheon core and some help from coming in from the side? Some people know this as an open innovation model, kind of made popular by Procter & Gamble years ago, now dramatically increasing part of Procter & Gamble's end-of-the-day returns as things that have been started through this model. We have a little bit of a hybrid model because we rely on that bottom V as well, which is more of a traditional IR&D view or a research and development view. So essentially what we're doing is combining a lot of elements from the venture capital community, the open innovation community, and the traditional research community, and a little bit of government and the labs and those kind of things come in from the sides. The model essentially is iterative, developmental, and simultaneous. And what do I mean by that? When something is iterative, what we're doing there is going through what I just described to you, the top-down problems, bottom-up solutions, going through that multiple times, seeing which one sticks, seeing which ones make sense. Meanwhile, developmentally, the technology is marching on in parallel or simultaneously. So very often you start out with a solution-agnostic problem and solution, and after a while it's not so agnostic. You're starting to get some meat on the bones. You're starting to see a solution take place. You're starting to pick on a couple of technologies that look like they're going to work, and you're funding and developing those technologies in parallel while you are working on your business case, working on your partnering, working on your funding, working on government policy. So you can see how that would lead us to a conference like this, because all of those things are happening here today. We've heard almost all of the speakers talk about this idea of a policy, technology, and solutions. So there's a little bit more to the model, which we won't go into today, but there's a lot of moving parts. Essentially what these are is it comes down to a business plan. At the end of the day, it does have to make sense for our shareholders. We have a fiduciary responsibility for them, but we also, as I mentioned, feel as though we have a responsibility to society as a defense firm. When those two meet, when we can make money and do a good job solving real problems, it's a win-win. So in just 5 short years, this group has developed quite a portfolio of projects. There's several in the food area, and I think somewhere there you can see a little chicken glowing. We are working on heating hatchling chickens faster and more efficiently for that, essentially the food producers of the world. We're working on animal health, starting with some bovine issues. Over here on the environmental side and energy side, we had one of our big successes with an oil from shale technology we sold off a few years ago. There's robotics. We have a maglev train project, which is working on a very, very large scale in the southeast here. We do a lot with education, with STEM, which is basically this idea of science and technology, getting that into the high schools, getting kids excited about that. And it goes on and on, really. There's a lot of healthcare ones we're working on, and so on. So it's a very diverse portfolio for a very small group, and the projects move rather fast through that model. What doesn't make sense gets discarded, and if we can, we put the ideas right back through the top of the V and try again until something sticks that makes sense. Out of that came 4 energy projects, which I'll talk to you about. One of the first ones that I'm going to mention is one I'm familiar with fairly well, which is essentially a cellulistic biomass pre-treatment project. And what we're doing there is working in a little bit different way than some of the more popular cellulistic pre-treatment methods, and we're using some of the Raytheon core technology to pre-treat. That led us to naturally to take the second step and say, well, we could pre-treat it more efficiently and produce better precursors to that oil. Maybe what we could do is then take a systemic view or systems view and look at the entire treatment and production system, and that led to essentially 2 projects in one. Another project that is being managed actually by the same program manager is an advanced wind sensing project. Again, looking at world problems, he saw that wind energy was an up-and-coming field. Then he went back into the Raytheon toolbox and said, what do we do well? Well, one of the things we do very well is predicting weather and understanding wind currents and energy currents all around the world. Most of that data comes from us. And he said, well, why don't I put those 2 together? And what this is a radar that looks out ahead on the horizon, understands the wind currents coming in, and proactively adjusts the wind turbines so that they are more efficient before, during, and after they receive the wind gust. And you can get a small but very important increase in a wind farm, an existing wind farm. And that one's very exciting. We're looking for partners on that one. Another guy in our group said, hey, one of our expertise is working essentially with electronics. We do a lot of wafer fab. What can I do in the solar energy area? And he came across a way of essentially dramatically increasing the power a traditional solar cell can produce. So now what you can do is taking existing infrastructure, people who already make solar cells, you can come alongside them with your technology and say, hey, why don't we license, why don't we partner, because I can make that cell of yours produce more energy for the same cell. And that project is up and coming as well. This is a project that I'm a program manager of currently, and essentially what we're doing here is saying, we looked around again at the top of the V about 4 years ago, and we said, what's big out there? And we kept coming across this number that there's 13 billion tons of CO2 produced per year from stationary plants. These are things that are bolted to the ground that you can see and touch and go up to. And we've heard some people today talk about similar numbers where essentially the effluent comes out the stack, and you can capture that if you wanted to. So we're talking about cement kilns, steel, aluminum, and power plants. And if you look at those around the world, they produce roughly 1/3 of all CO2 pollution in the world. These are things that are very easy to go up alongside of and capture that CO2. Then the question becomes, well, what do you do with it? right? And there's people that use it in secondary and tertiary oil recovery. That's a good way. There's other people talking about some other things. We said, well, those are all nice, but essentially what at the end of the day is it's still CO2 gas. Why don't we do something else with it? Why don't we make it into a solid? And so what we've done is developed some nano aerogels that we mix in with the CO2 stream, and we pump it underground, and then we activate it with some specialized RF energy, and then it's no longer CO2, it forms a carbonate. So now essentially what you have underground is a very inert, safe solid. And to give you a rough example of magnitude, there's an abandoned salt mine in the UK, very average size mine, abandoned, very typical all around the world. It would hold roughly 16 power plant years worth of CO2, and you could pump that down there. So the average mine can hold that much. So you can imagine the volume of CO2. What's exciting about this technology is that you're looking at all three legs of the stool we've heard today. The amount of technology and the amount of jobs that would be produced if this became an industry is tremendous. You have very, very advanced pumps, piping, liquid handling systems. You're going to have nanotechnology development and production factories, which are already in existence in the UK. They actually make these kind of things, and in Germany. So there's a lot of handling equipment. Much of it already made here in the United States. Some of it's made in Europe and in Asia. There's a systems component to this where you would have high-end engineering type jobs created, essentially working on the systems view and getting all the balances down. So it's a very fun project. And oh, by the way, at the end of the day, you're helping sequester CO2 permanently. So that's a good thing. Okay, so I think we'll go here. That's sort of an artist concept of the view. And you can see we just sort of, for fun, put a power plant. It's a coal-burning or oil-burning power plant that happens to be just a couple miles from this ideal mine site. And we truck the CO2 over. And there's a little bit of a power grid that you need to activate it. And those are the three elements going down. So one of the things I like to say is that this is one technology for greenhouse gas sequestering. We believe it's a great one. We are very excited about it. But it's not the only one. It will work well in certain circumstances, in certain formations around the world. There are many others up and coming. They will also work well in certain circumstances. You need lots of them. And we're going to need, much the way we've heard from Ford, there's essentially a portfolio view that needs to be produced. And that portfolio view of multiple technologies, the banking community and the government community need to have a similar view so that the whole pie comes together. And it's been very encouraging for me to be here today because I already hear that view happening. And